Welcome everybody. Welcome to this session. In this section, Stacy talk us about the static web app and authentication. I remember you that it is possible use the Q&A section on Teams for make a question. And Stacy, you are ready?
Yeah, I'm ready.
Wonderful. You can share your screen.
Okay, so in the immortal phrase from the last 2 years, can everybody see my screen?
Okay.
Not yet.
No, you are online.
Am I online? Okay, because I don't see my screen in the preview window from the Teams meeting.
Yes. Yeah, in the preview, they were your screen, and if you want, no, I cannot share your webcam
Okay.
because
As long as everybody can see it, that's fine.
Because no, I have a problem with Teams, and now I cannot share the presenter webcam. I don't know why.
Okay,
It's broken for me. Sorry. Let's go.
let's go. Okay then.
Yes.
Well, good afternoon, everybody. Good afternoon to those who are joining me from the European time zone. Hello, whatever time of the day it is, to everybody else. Thanks for spending some time with me this afternoon, where we are going to be talking a little bit about authentication in Azure Static Web Apps and how we can code with authentication in Azure Static Web Apps. So, a little bit of an introduction. I absolutely adore Azure Static Web Apps. I've been using them since, well, when they were in preview. So I've been using them for more than 12 months now. And I find them a really quick and simple way to get applications out to the web. So previously, we had to have a lot of different resources in order to get an application out. If we're going to do a static web app, we would need a storage account, some Azure functions, make them talk to each other nicely. And that's now been replaced with this single Azure resource where we have our static files for the front-end application in whichever front-end language you like to code in. Today, we're going to be looking at Blazor WebAssembly. And then a backend API written as an Azure function, again, in whichever language you want. We're going to be using .NET today. But on top of the code for your application, there's code built into Azure Static Web Apps that glues that front and back end together and turns it into a single useful application. Now, part of that glue, part of that code is the authentication process. For the free tier of Azure Static Web Apps, there are a number of authentication providers which we get out of the box, and they are implemented in such a way that it makes authentication and authorization really simple, even if you are not an expert in that area. Now, if you want to provide your own authentication provider on top of the ones that are available out of the box, you can do that too if you use a standard tier static web app. I believe that's about $10 a month or so for one of those. We're not going to be looking at that today, but it's useful to know that it's there. So, hello everybody, a little bit of an introduction. I am Stacy Cashmore. I am Tech Explorer DevOps at Omniplan, a company that provides financial advice software based in Amsterdam in the Netherlands. I have been writing software since the middle of the 1990s, and for the last 2 years, I've been honored to be able to call myself a Microsoft MVP for developer technologies. A little bit of a something I need to say first of all. I am recovering from COVID right now, so if I run out of breath, you'll see me stop for a couple of minutes. I'm fine. We'll get back to it pretty soon afterwards. So before we have a look at any of the code, I want to have a look at the application that I'm going to be using to demonstrating what we can do with authentication in static web apps. Now, anybody who has scaffolded a Blazor application using Visual Studio will probably recognize most of this. It's almost out of the box and standard, except for two things. We have this auth provider information at the top instead of the link to the ASP.NET documentation. And we have this login button. And this is just something that I've added so that we can see the authentication in use. So if we log in, we can see that we have an option of 4 providers. Now, this is on the free tier, so these all come out of the box. And we can sign in with Microsoft, or more accurately, we can sign in with Azure Active Directory. We can sign in with GitHub. We can sign in with Twitter. And at the moment, in preview, we can sign in with Google. Now, there is a 5th one, which is kind of available and kind of not available right now, and that's Facebook. You can try and use it, but you need to be part of a private preview, I think. So I don't have that on my screen because it won't work for me. So let's try and sign in with Twitter and see what we need to do. Now, if I click on this button, I'm going to go to a special place inside of the Azure Static Web App that I've not made. You see that we go to Twitter and then we come back in, and that's it. I'm now authorized. So my authorization provider is Twitter, and I've logged in as a standard user. So what just happened there? Well, inside of a static web app, we have a .auth folder, which isn't part of my code base at all. This is the glue inside of the Azure Static Web App. And there we have a number of pages available. One of them is Twitter. And that will then go out to Twitter. It will authenticate us. It will get the token that we need in order to continue communicating with our application. And it does so in such a way that hides the details from us so we don't need to know about it. This means that if we want to see how we're logged in, we don't look at the JWT token because that's all taken care of by the Azure Static Web App, but rather we go to this page, .auth/me. When we come to this page, let me zoom in so you can see that better. We get a JSON object returned to us, which tells us a little bit about the user that's logged in. We get a very small amount of information, but it's enough to work with. So I logged in using Twitter. I have a user ID, and this user ID is for me for this static web app. So I'm not doxing myself by giving you my user ID here. For every Azure static web app that I log into, I will get a different user ID. Then we have the user details. Now this changes depending on which auth provider you use. So I've logged in with Twitter. So what I see here is my Twitter handle, which is @Stacy_Cash. If I log in with GitHub, I get my GitHub handle. If I log in with Azure Active Directory or with Google, though, what I get back is my email address. So you need to know what to expect to get back from the authorization providers depending on how you want to use this information. Finally, we have an array of user roles. Now, every user that logs into your site using this method gets 2 user roles by standard. They get anonymous and they get authenticated. We can add more user roles and we'll be looking at that later on, but these are the 2 that you get out of the box. So with no code, let me reset that a little bit. With no code on this site, we've managed to authenticate with an external source, and we can now use the information from this user inside of our application. This is awesome. I love code that I don't have to write, because code that I don't have to write is code that I'm not probably going to put bugs into. But there is a small problem here. This all happens inside of the Azure resource in the cloud. When I'm trying to develop my software, I don't have that available to me. So what do we do then? Have I got to do all my coding, upload it to the cloud, check to see if it works, and then recode? Or can I run this on my machine? Well, I'm pleased to say I can run this on my machine. There is an application available right now called the Azure Static Web Apps CLI. So let me just bring that down here. Come on, resize window. And this is an NPM package that you can install on your machine. And what it will do is replicate the functionality of an Azure Static Web App on your local machine. Now, I'm not going to go through everything that you can do in the Static Web App CLI today, because that is quite literally a talk in its own right. But we're going to be using this to do some local development and see what it is that we can get from the application. Now, I said that this replicates the Azure Static Web App, and it's really important to note that that's all it does. It doesn't give you exactly the same functionality. It's a Node.js server which kind of behaves like an Azure Static Web App. So if you're using this to test things, always make sure that you do run in production or do run in the cloud before you actually go to production to make sure you don't get any surprises. So the command that we're going to run here in order to start our application is SWA for the Static Web App, start, which I believe is the only command which is supported by the CLI right now. And then we have HTTP localhost 5000. That is the development server URL for .NET. So this is where the Static Web App is going to forward all of our requests to. Then we have a flag for the API location, and that is pointing to a folder inside of my repo, and that folder contains an Azure function. If the Static Web App CLI finds an Azure function in that folder, it will try to run it, and it will use that Azure function for all of your API calls. So anything that goes to /API gets put to your Azure functions. Finally, we have this run flag. I said that I'm pointing to HTTP localhost 5000, the development server, so I need to run it as well. So that's what this run command does at the end. We're just starting .NET Watch run, and we're pointing the project to the client folder. So we have the API and the client. Now, we run this, and we hope that my machine is reasonably quick when sharing it on a Teams call. And there we have it. We now have this new URL, localhost 4280. Now, this will give us, if I run it inside of my browser, without the dot on the end, something which looks incredibly similar to what we're running in production, which is kind of what we'd hope, because it is that application. But now we're running, we can see that we're not logged in, so we still have some auth information. So let's see what happens when we try and sign in with Twitter locally. Well, we get a very strange screen. This is not what we saw before, and that's because my local Static Web App CLI, that doesn't have the right to go out to Twitter and to do that whole authentication process. I need to fake that here, and we're doing that just via a page where the Static Web App CLI lets you create your own user on the fly. So we have the Twitter provider, because I clicked on that Twitter link. We can see the URL at the top, auth login /Twitter. We have a user ID, and this user ID is entirely free form, so we can change that to end in B. We can change the user ID on the fly. We have a username which we can change as and when we want to, and then we can set those user roles that we had before. So if I log in now, my auth provider still says Twitter. It still thinks that I've got that Twitter user. I'm still logged in as a standard user. And if we come back to that auth me page, we can see that in a different style of formatting, we still have that same JSON object. We have a client principal with that user ID that we created ourselves, with the anonymous and authenticated user roles. The identity provider is Twitter, and our user detail is test user. So running it in this way, we can develop locally, we can debug locally, and we can try and see what's going on inside of our application. Now, having these faked endpoints can really save us a lot of time and hassle when we are developing Azure Static Web Apps. I've worked in many teams where we've needed logins in order to be able to develop, in order to be able to test. And it's always bureaucracy that's overhead when you're trying to get work done. By using this way, we don't need an account for each of the providers that we want to test because that happens outside of our control. We can just use these fake accounts. We can log in however we want. We can set up the user however we want. So we don't need any accounts externally. We can just do them for ourselves. Because we don't need those accounts externally, we don't have an issue if we want to test with different roles. We don't need different users for that. We can change our roles on the fly and see what happens to the application when we do that. And finally, if you are working in a team and you have a test user that has a seeded account with a load of data that this test user should be able to see, you can now share these between your teammates without actually having to share a username and password with all the security implications that comes with that. Basically, I think this removes a lot of the bureaucracy and overhead when it comes to testing with users that you need to log in with. So let's change part of our system now. Let's go into our log out. Then we're going to log back in again, still with Twitter. And we're going to log in as admin. And if we log in as admin, then we can see that I still have a standard user. Something's not working right here. Let's have a look at the code and see what this is actually doing in the background. So here I have my solution for the site. I have an Azure Functions API. I have a Blazor WebAssembly client. And in order to gain access to that information, we need to set up an authentication provider. This flow starts inside of our program CS, where we add to our services Static Web Apps Authentication. Now, I got this code from Anthony Chu. I've changed it a little bit to make it a little bit more usable inside the application, but I want to give credit where credit's due to the base idea. When we add Static Web Apps Authentication, we do two things. We add Authorization Core, which comes from the Microsoft ASP.NET Core Components Authorization namespace. And we add an authentication state provider. And for that, we're using a Static Web Apps Authentication state provider. So we have to override get authentication state async. And when we do that, we do two things. First of all, we're going to get a client principal, and then we're going to get the claims out of that client principal. So let's go to the get client principal first. And what we do is make a HTTP call to that auth.me endpoint. Because we're working in Blazor WebAssembly, when we make that call to the endpoint, all of the standard headers are passed along with us. That includes that security token for the Azure Static Web App. So you make the call to auth.me, it knows who is making that call, and it can return that JSON information to you, that client principal. So then we deserialize that data into a client principal, and this just literally replicates what we've seen: identity provider, user ID, user details, and an IEnumerable of user roles. And then if we get back to where we were, once we have that, we can get the claims from the client principal. And this code, the first thing that we do is strip out that anonymous user role, which seems odd. Why are we stripping out a user role? Well, if somebody's anonymous, we don't actually care. If you're logged in as anonymous, or if you're not logged in as anonymous, we're just going to treat you as if we don't know you, if that's the only thing that you have available to you. And there we see that on the next line. If user roles.any, if we don't have any user roles after we've got rid of anonymous, we return an empty claims principal. We class you as not authenticated. If you do still have roles left over, then we make a claims identity based on the identity provider of that client principal. So that would be Twitter in the examples that we've just seen. we add the user ID to the name identifier, and we add the user details to the claim types.name. I always find that one a little bit odd that we're adding either an email or a handle to a name, but it is what it is. It's all we have available to us. Lastly, we take any claims which are left in those user roles that we got from the JSON object, and we add those to our claims object. We return that, and now we have an authenticated user that we can use inside of our application. The next thing that we need to do in our application is add a cascading authentication state to our app.razor. So we need to wrap that around our Blazor router. Once you wrap this at this point, we can now use that authentication state in any one of our components. It gets passed in automatically. Now, in our demo, we saw that I use that in two places. We use it at the top for the authentication type, and we use it for the login button. So let's have a quick look at the main layout to see what we're doing there. On the top row, we have this authorized view. And inside that authorized view, we have two options, the authorized and the not authorized flow. If you're authorized, then I just use the context user identity authentication type exactly as you would do with any other authentication inside of a Blazor application. And if you're not authorized, then I just simply say not logged in. And for the nav menu, it's kind of the same thing. We still have this authorized view with the authorized and not authorized view. If you're not authorized, then we just have a link to the login providers. You don't need to use that login providers page, but I do because it just gives me the chance to use all four really simply without having to remember URLs. If you are authorized, then I give access to the .auth logout so that you can log out if you want to. And then I get information about the user, standard user or super user. So it's not admin, it's super user that I need to use. So let's just check that that's working locally, shall we? So let's log out of our standard user. Let's log back in again. Let's go to Twitter, and we'll change this admin to be super user. And everything's working as it should do. So that is how we authenticate or use the authentication in that client. What about inside of the API? Well, that's slightly different. And that's slightly different because inside of the API, you can't make that call to the auth/me. The API is not running on the client. It doesn't have that JWT token available to it from the Azure Static Web App in order to get that information back. But thankfully, Azure Static Web Apps have us covered here. I have an example function here which does nothing more than return information about the claims identity that somebody's using. And what it does, we pass the HTTP header for a client principal instead. When you make a request to the API structure of an Azure Static Web App, before it reaches your Azure Function, it will have this header added to it, XMS client principal. If we have this available, then we decode the base64 string, we turn that into JSON, and then we deserialize that JSON to exactly the same claims principal that we had before. Once we have that available to us, we can then use literally exactly the same code to figure out if this person should be authenticated, and if they are authenticated, what roles do they have available to them. In this way, we can safely use data associated with our user further in our application. So if I've got something where users should be able to save data and then recall it back later, then obviously I can use that user ID in order to partition my data to save and load the data and ensure that nobody else has access to data they shouldn't see, and that I can't save data to somebody else's account. So that's how we can use data inside here. But what about ensuring that people can only access APIs that they're supposed to access? We can do that with the claims principal. We can recover the claims principal. We can check whether or not you have a role associated with your login, and then we can return an unauthorized for that login. Or we can use built-in functionality for this too, which is what I would recommend, because again, it makes our life easier as developers. Every static web app has a static web app config.json. Now, you can control a whole bunch of things inside your application using this. Again, that is a talk in its own right, so I am not going to go too deeply into it today, but I'm going to cover two functions that this can have. The first one is our top 3 routes here, where we say for API authentication test, you have to be a super user. For authentication test 2, you have to be authenticated. And for our counter application, you have to be authenticated. So let's have a look at that one in real life on our site. First of all, we're going to log out. So we have nothing available to us. If I go to my authentication test, I get a 401 unauthorized. It's kind of what we would expect. I go to 2, I get that same unauthorized. This is good, 2 for 2. And if I go to counter, I still get that unauthorized. So using this, I can stop people going to the static web app and requesting resources that they shouldn't have. One thing that I do need to point out, though, that you need to remember with applications that run inside the browser, when I go to the static web app, I can verify if somebody has access to something. Once the application is loaded inside of the browser, I don't necessarily need to make a round trip back to my server again. So my counter app here, I can click on inside and it works perfectly. It's only when I refresh it that I get that unauthorized view. So always make sure that, yeah, for your routes, you can and you should use that static web app config. Inside of your application, you still need to make sure in the actual C# code that people can't see links and can't see pages that they're not supposed to see. And you do that again using that authorized and not authorized view. So now let's log in. And we're going to get rid of the super user. So now we're just authenticated and we can now go to the counter and we can see it as we'd expect. We can go to the authentication test 2 and here's that information back that we again expect to get. And the authentication test, we get a 401 unauthorized. Again, exactly what we want. One thing to note at this point, we're getting a 401 unauthorized back. This is not the same as it is inside of the Azure resource itself. In the Azure resource, you get a 403 forbidden response back from the server. It might not be overly important to your application, but it's just a reminder yet again that just because it looks like you're running in Azure Static Web App locally, you're not. You've just got that functionality replicated. And finally, just to prove that this really does work, we're going to go back once more with Twitter, and we're going to say that we are a super, if I can type, user again. And now, as you would expect, when I go to authentication test, I get that data back as well. So limiting access to our API is really simple to do using that static web app config. I'd advise you to take a look. The other thing that you can do using that static web app is limit access to the actual authentication providers. And that's what our last route does here. Why do we want to do this? Well, maybe that you only want to offer your application for Twitter users or for GitHub users. Maybe it's something that's really built into those. It's closely built to those apps, and logging in using Google doesn't make sense for you. In those cases, what you do is redirect your route, so the .auth login AAD, redirect that just to a 404 page so that people can't use it. And you can see I've got it for Active Directory here. So when I come back to my app and I log out again, Now, when I try and log in, if I go to Microsoft, I get a 404 not found. And obviously, you can also catch the 404 route. You can make this a much prettier page than it is right here. It can also be, of course, that if you are using your own authentication provider, you have a standard static web app and you've implemented your own authentication provider for your company, that you need to disallow all of these because you only want to use your company's login. So that is how we can handle limiting access to different authentication providers. The last thing that I want to show you is setting up roles. We've seen roles being used inside the app. We've seen what we get back from that client principal, but how do you actually add that to your users when you're running in production? Well, for that, we have this role management inside of the Azure portal. Now, on this page, you can grant up to 25 users explicit roles inside of your app. That doesn't mean that you can only have 25 authenticated users inside of your app. It's just those explicit roles. For the majority of your users that just access your app, they don't need anything here. It's only if you want to give somebody that super user role that you need to do something with. If that's not enough, then you're going to need to take a paid account, that standard tier. And if you do that, in this page, you can add up to 25 different users for your app, which sounds fairly similar. And I really don't know why, but even on a paid account, you can only have 25 roles in this page. What you can do for a paid app, though, is implement your own role management through use of a specialized Azure function. If you do that, you can have as many roles as you want, as many users as you want. You have to handle it. Like I say, we're not covering that today, but it's important to know it's available. What we are going to do is show you how to make a role. So we're going to add GitHub here. Also important, see, I've still got Azure Active Directory, even though my app doesn't support it. So when you're creating an invite link for somebody, make sure that you use the correct authentication provider and they can actually log in using that method. I'm going to create an invite for Stacy Cash. That is my GitHub handle for SWA auth stacyclouds.dev. And I want a super user role creating. So when I do this, I get a link which I can then email out to my user so that they can use. And if I bring this into a new browser window and log in, I have to grant consent because this is the first time I've logged in with this account on GitHub. So I'm going to grant consent for my email address and username. And now when I log in, I'm this super user, and that should mean that I can go to my authentication test and everything works as we expect it to. So that's how we set up roles, and that's how quickly you can set up roles and get it working. Something to know here that's important, it can catch you out if you're not aware of it, is there's an amount of caching that goes on in this screen. If you change somebody's role, or if you remove somebody from their role, it can take, I've had it take up to half an hour or so before it actually appears on the website. So if I remove this user now, and then I log out and log in, you watch this now work instantly. Nope, there we go. I'm still a super user, even though I've removed that role inside of the application. So this isn't an instant kicking of a user. It takes a little bit of time for it to filter through. So looking at the time, that is what I wanted to show you today. It's been a lightning tour of authentication in an Azure Static Web App, again, using that free tier. We've had a look at the different providers that are available to us, how to access those providers, what information we get back when we log in, and how to use that information, both in a Blazor front end and in an Azure function on the back end. We've also seen how we can limit access to certain resources, both based on authentication and on the role of the authenticated user. And we've had a look at how to remove providers that we don't wish to support. As I said, there are more options available on the standard tier of the Azure Static Web App. but we have covered the basics that you need to know here in order to get started. It has been a little bit of a whirlwind tour, but if your interest has been piqued, then I really suggest you take a look at the documentation that's available on Azure. I'm going to be posting that to my Twitter feed after I finish speaking today. And I'm also going to post information on the authentication, the quotas for the roles, the repo that I used to make this demo application so that you can look at it yourself, and also to Anthony Chu's authentication repo, because that's where I got my ideas from, and I think it's good to credit the right people. I've been Stacy Cashmore. I hope you've had a great conference today, and I hope you've enjoyed this session. Have a good rest of the day. Do we have any questions, Leonardo?
I'm sorry, I'm here. Yes,
Okay.
there were a question. 1 second. Okay. What's the name of... sorry, okay. What's the name of that utility used in order to mock the presence of external identity provider in our dev test?
That is the Static Web App CLI. I will also put a link to that on Twitter as well for people so that they can go there. It is a tool. It is in preview at the moment, so it can change as you use it, but it's fairly stable these days. And you install it using npm. It is a Node.js server that you run on your machine, and it just replicates an amount of the functionality available in Azure Static Web Apps. And some of that functionality is the authentication. And so that gives you the page that you can use to just enter whatever data you need to do in order to test your application.
Okay. Another question. Is possible to create invitation link with the API, or is possible only in Azure portal?
I'm going to be honest, I am not 100% sure there. I've only ever done it using the portal, but I will have a look this evening and I'll have a play, and I will put that on Twitter too.
Wow, okay. Damiano say, but the provider will set on Azure Static Web App?
I'm not sure if that means
I don't know, because it starts with a but. It's a part of a sentence, but okay. Sorry.
I'm assuming that is if you set the providers that you want to use inside of your application, it doesn't link to the Azure portal at all. The Azure portal doesn't know what is in your static web app. That's only at the point where you run your application. So assuming that that's what the question is referring to, it's no, it's you have to remember which authentication providers you're using, which I'm guessing in the real world you're going to be doing. But yeah, it's just something to keep in mind.
Okay, that's all.
Okay, then. Well, thank you everybody for your time. Thank you for the questions. The question about the invite link, it's something I've been meaning to investigate, so this gives me an awesome opportunity to actually do that myself. I will do that, and I will share my results in the on my Twitter feed later on today.
Okay, bye.
Okay, bye-bye, everybody.
Bye.